Hi class. So in last video for chapter 7 class 1, we talked about some basic concepts for interest rates and the determinants of interest rates. Okay, we had the two groups of concept, which is nominal rate versus real rate. Okay, nominal rate minus inflation rate equals real rate. Okay, the other group of concept is risk-free rate versus real risk-free rate. Okay, the nominal risk-free rate minus inflation equals real risk-free rate. Okay, and then we talked about some risk premiums, including inflation premium, IP, market risk premium, MRP, default risk premium, DRP, and liquidity risk premium, LP. And we were talking about the equation of how we calculate bond interest rates, R. Okay, R equals real risk-free rate R star plus IP inflation premium for all funds. But for long-term bonds, we need to add MRP maturity risk premium. And for corporate bond, we need to add DRP and LP, default risk premium and liquidity premium. Okay, and then, okay, so let me show you the equation again. Okay, so this is the comprehensive equation on bond interest rate. Okay, R equals R star plus IP plus DRP plus LP plus MRP. Okay, and for short-term treasury, it only has the first two elements, R star plus IP, because it's short-term, so it doesn't have MRP. Because it's treasury bonds, so it doesn't have DRP and LP. For long-term treasury, it is long-term, so it has MRP. But because it's treasury, so it doesn't have DRP and LP. For corporate bonds, they have DRP and LP, but for short-term, it doesn't have MRP, and for long-term, it does. It does have MRP. Okay, and for term structure and yield curve, we talked about that term structure is just the relationship between interest rates, R, and years to maturity, T. Okay, and typically when T goes up, IP and MRP goes up. So the R interest rate goes up. And we were trying to construct a yield curve to show the relation between T and R. The first step is to calculate IP, okay, for different T. And then we're going to calculate MRP for different T. And we add these to real risk-free rate so we can know the R, the interest rate, for different bonds with different T, different maturity. Okay, so I hope you saw for our example already from last video. Here is an example of how we can calculate inflation premium, IP, by using the inflation rate from year 1 to year n and divide by n. Okay, so this is taking the average of the inflation rate for n over the n years in order to calculate the inflation premium for a bond with n maturities. Okay, so in this example, we know that the inflation rate is gonna be 5% for the first year. For the second year, it's gonna be 6%. For the third year and all the years afterwards, it is 8%. So if we want the 1 year inflation premium, it is just the 5%, the inflation rate for the first year divided by 1, which is 5%. If we want the inflation premium for 10 years, we need to use the inflation rate for the first year, 5%, plus the inflation rate in the second year, 6%, plus the inflation rate in the third year, which is 8%, and also add all the inflation rates from the third year to 10th year. Okay, so we need to add 8 times 8%. Okay, we need to add 8% for 8 times for 8 years from year 3 to year 10. Okay, so we can just use 8 multiplied by 8%. Okay, and then we divide by total number of years, which is 10 years. Okay, we use the inflation rates for each year for 10 years, add them up and divide by 10. So we can have the average inflation rate as the inflation premium, which is 7.5% in this case. Okay, we use 8 multiplied by 8% because we add 8% for 8 times. For inflation premium for 20 years, we use 5% plus 6%. Okay, these are inflation rates for the first and second year. And then from the third year to the 20th year, we need to add 8% for 18 times. So we use 8% multiplied by 18. And then we divide by 20 years. So the average inflation rate or inflation premium for 20 years is 7.75%. Okay, so here, this is how we calculate inflation premium for 1 year, 10 year, and 20 years. We add up all the inflation rates for each year and divide by n. Okay, let's look at a practice problem here. Suppose the real risk-free rate is 2.5% and the future rate of inflation is expected to be constant at 4.1%. What rate of return would you expect on a 5-year Treasury security? Disregard cross-product terms. If averaging is required, use the arithmetic average. Ignore maturity risk at this stage. Okay, so it's a 5-year Treasury bond, so it should have MRP, but we assume there's no MRP. So our formula would just be R equals R star plus IP. Okay, we don't have DRP or LP either because it's a Treasury bond, not corporate bond. Okay, for here, our star real risk-free rate is given as 2.5%. IP inflation premium should be always 4.1% because inflation rate is constant. Okay, so the average is also 4.1%. So here, the interest rate is 2.5% plus 4.1%. So we have 6.6% as the interest rate for the Treasury bond, or we can say it's rate of return for the Treasury bond. All right, step 2 of constructing a yield curve. Okay, remember step 1, we calculated IP using the average of the inflation rates over the n years. For MRP maturity risk premium, the longer term the bond is, the higher the MRP is. Okay, so here we have an example, and in this example we have the equation given that MRP for bonds with T years, okay, is 0.1% multiplied by T minus 1. This is the equation we will be using to find a security's appropriate maturity risk premium. What is the 1-year MRP? What is 10-year MRP? And what is 20-year MRP? Okay, so here T could be 1, 10, or 20. So we can just plug the number into this equation. MRP 1 equals 0.1% multiplied by 1 minus 1, so it's 0. Okay, remember for short-term bonds within 1 year, usually we assume there's no maturity risk. So MRP is 0 here. Okay, when T is 10, MRP 10 equals 0.1% multiplied by 10 minus 1, so we have 0.9%. MRP 20, this is 0.1% multiplied by 20 minus 1, so we have 1.9%. Notice that since the equation is linear, the maturity risk premium is increasing as the time to maturity increases, as it should be. Okay, so for this equation given by the example, it follows our general pattern of MRP that when T is higher, MRP should be higher. Okay, the longer the term is, the more maturity risk the bond has. Okay. So interest rate will increase as MRP increases as well. All right, adding premiums to R star. Example, assume real risk-free rate is 3%. IP and MRP are what you get above. Okay, now we're coming to step 3. After we calculate IP and MRP, let's add them to our real risk-free rate to get 1-year nominal rate, 10-year nominal rate, and 20-year nominal rate. Okay, and again, because this is treasury bills, we do not have LP liquidity premium or DRP default risk premium. Okay, so again, please pause this video. Okay, try to look, try to refer to step 1 and step 2 results, and please try to calculate the nominal rate for 1-year, 10-year, and 20-year bond. Okay, you can pause the video, try to solve this question yourself, and then we'll come to the solution after you finish working on this on your own. Okay, you could resume the video now if you have finished the step 3, and let's look at the solutions here. Okay, again, because this is a treasury bill, so we do not have the RP and LP. Okay, we just need to use the basic formula. R interest rate equals to real risk-free rate R star plus IP inflation premium plus MRP. In this question, we know R star, real risk-free rate is 3%. It's given. Okay, so for 1-year bond, the nominal rate is 3% plus IP that we've already calculated in step 1 as 5%, plus MRP we calculated from step 2 as 0. Okay, so we have nominal rate or nominal interest rate for a 1-year bond as 8%. For 10-year bond, we still start from R star, 3%. We add inflation premium for a 10-year bond, which is 7.5% from step 1, plus the maturity risk premium for a 10-year bond. And we have it from step 2 as 0.9%. Okay, we add these numbers up. We have 11.4% as interest rate for a 10-year bond. Interest rate for a 20-year bond. We just need to use the real risk-free rate 3% plus the IP 20, okay, inflation premium for 20 years. It's from step 1 and it's 7.75%. Plus MRP 20. From step 2, we know it's 1.9%. So the total interest rate for 20-year bond is 12.65%. Okay, so you can see that in this example, it's a typical case where when T increases, our IP increases, and MRP also increases. So our interest rate R increases. Okay, so here R and T has a positive correlation. When T increases, R increases. So the slope for the yield curve is upward sloping. All right, let's discuss another terminology here or concept here, which is the relation between treasury yield curve and yield curves for corporate issues. Typically, corporate yield curves are higher than that of treasury securities, though not necessarily parallel to the treasury curve. Since corporate yields include a DRP default risk premium and the LP liquidity premium, the corporate bond yield spread can be calculated as, okay, so we define corporate bond yield spread as corporate bond yield minus treasury bond yield. Okay, so it's the difference between a corporate bond interest rate and treasury bond interest rate. And difference is just the premiums that only the corporate bond has and treasury bond does not have, which are default risk premium and liquidity premium. Okay, so the sum of DRP and LP, we can call it corporate bond yield spread, the difference between corporate and treasury bond. Okay, alternatively, we can derive from 6.3. Okay. Okay, so alternatively, we can derive by using the equations for short-term corporate and long-term, short-term corporate and treasury and long-term corporate and treasury. Okay, remember for short-term corporate, the formula looks like this because it's corporate bonds, so we have DRP and LP. Because it's short-term, so we do not have MRP. For short-term treasury, R equals R star plus IP, nothing else. Okay, so the short-term corporate and short-term treasury has only the difference of the sum of DRP and LP. Okay, for short-term corporate and short-term treasury, they both have R star and IP, and none of them has MRP. Okay, so the only difference between these two, if you use short-term corporate interest rate minus short-term treasury short-term treasury interest rate, you will only have DRP and LP left. Okay, for long-term corporate, alternatively, we can just look at long-term bonds, and for long-term corporate, it is R equals R star plus IP plus DRP plus LP plus MRP. For long-term treasury, R equals R star plus IP plus MRP. Okay, so the difference between these two is just DRP and LP. They both have MRP and they both have R star plus IP. Okay, so short-term corporate minus short-term treasury equals short-term corporate, long-term corporate minus long-term treasury. So we only have DRP and LP as the difference between corporate and treasury bond. Okay, and we call it corporate bond yield spread. Okay, and this spread between corporate and treasury yield curves widens as the corporate bond rating decreases. Okay, because when corporate bond rating decreases, it means that the firm becomes riskier. So default risk premium and liquidity premium will increase because of the higher risk. Okay, we can see this on the graph here. For example, if we're looking at 5-year bonds, okay, and we're comparing US Treasury, 5-year US Treasury to 5-year corporate bonds. And for corporate bonds, we have AAA, AA, and A bond. Again, US Treasury bond we think is safest, okay? It almost has no liquidity risk or default risk, so it has no LP or DRP. So the rate, okay, the interest rate for US Treasury 5-year bond is 0.83%. And DRP plus LP, the corporate bond yield spread, is 0. Okay. However, when we go to AAA corporate bond, interest rate now is higher because it has some default risk and liquidity risk. And the liquidity risk premium plus the liquidity premium and default risk premium add up to 0.1%. This is the corporate bond yield spread, and this is DRP and LP for AAA corporate bond. Okay, when the bond rating goes down, when we go from AAA to AA, okay, this firm is riskier than AAA. It has higher risk. So the interest rate is also higher. The rate of return is also higher because the DRP plus LP, the corporate bond yield spread, is higher. Okay, because this firm has higher default risk and liquidity risk, so it has a higher DRP plus LP. Okay, we continue to single A corporate bond. It has even higher risk. and the rating is also worse, or the rating decreases. So the interest rate goes up again because of the higher risk. And the corporate bond yield spread is DRP plus LP, which is 0.84. Okay, same thing here on the next graph, illustrating the relation between corporate and treasury yield curves. Okay, again, treasury bond, first of all these bonds have upward sloping yield curve. When T is going up, interest rate is going up. But in general, for bonds with the same T, treasury bond has lowest interest rate because of lowest risk, and it does not have DRP or LP. For AA rated bond, it is riskier and it has DRP and LP, and the rate of return is higher than treasury bond. For BBB rated bond, it has highest DRP and LP. It has highest yield spread, and it has highest interest rate because of the highest liquidity risk and default risk. Okay, let's look at the last graph here for treasury bond, AA rated bond, or BBB rated bond. We can see that from 1 year to 30 years, all these three bonds, they have an increasing interest rates as time goes up because of the higher MRP. Okay, but for bonds with the same maturity, such as 1 year bond, we can see that AA rated bond has a higher interest rate than treasury bond because it has higher risk. Okay, and BBB rated bond even has the highest interest rate because of the higher risk and because of the higher DRP and LP. Okay, same goes to 5-year bond. Treasury bond is of the lowest interest rate. AA rated bond has higher interest rate because of higher DRP and LP, and BBB rated bond has the highest DRP and LP and the highest interest rate. Okay, so that's all for Chapter 7, Class 2. Okay, we learned how to construct the yield curve by calculating IB, MRP, and add them to R star. So we have the interest rate R for long-term treasury bond for different maturities. And we also learned that the difference between corporate bond and treasury bond is DRP and LP, and we call it corporate bond yield spread. As the rating goes down, as the firm gets riskier, we have a bigger spread, larger spread. Okay, DRP and LP is larger. Okay, that's all for this video. From next video, we're gonna discuss Chapter 7, Class 3, and we're gonna focus more on the bond evaluation rather than the interest rate.